Welcome. Today's lesson is on balanced equations, molecular equations, total ionic equations, and net ionic equations. So let's get started with an example. This example is taken from your problem book, 516, 7F if you want to follow along, or you can just take out a piece of paper and follow along with us just on a piece of paper. So pause the video and either get out the problem book page or a piece of paper, and I'll wait for you. Welcome back. So hope you're ready to ride along with me. We have an equation of an ionic compound, barium nitrate, and another ionic compound, sodium phosphate. But before I balance this, I notice that I don't have any products. So the first thing I have to do is predict what the products are for this reaction. So if you remember, ionic compounds are positive and negative, positive and negative. So what type of reaction happens? Well, they swap the partners. So barium is positive, so now it's going to go with phosphate, which is negative. And sodium, remember we say the positive ion first, sodium is going to end up with nitrate. So let's put that together on the other side. So I have barium with phosphate. And this is a common mistake, just leaving it as barium with phosphate. I have barium here and phosphate here, but that's not how we write neutral ionic formulas. I need to have a net charge of 0, and barium is +2 and phosphate is -3, so I can't leave it as one barium with one phosphate. That won't give me something that's neutral. So if you remember how to make formulas, which I hope you do by now, I am going to need to take something that multiplies up to 6. So how many bariums do I need? I need 3 bariums and 2 phosphates. Then I'll have a +6 and a -6, and that will be a neutral compound. And if that's difficult for you to do, please review the videos on writing ionic formulas. So do that. So barium phosphate. And notice after the ionic compounds, we had a symbol here, AQ for aqueous. That means it's soluble in water. So I need to look up, is barium phosphate aqueous, soluble in water, or is it not aqueous? Is it insoluble, which gives it an S? So I look up those rules in Appendix A2 and find that all phosphates are insoluble except for those covered by Rule 1. And barium is not an alkali metal, so this is not soluble. So I'm going to put an S behind it. Okay. So I'm halfway done with the products. The next is sodium nitrate. And so I'm going to write that as sodium nitrate and put the positive cation first and the negative anion second. And a common mistake when people do these formulas is to carry the subscript over here. So this is not Na3. This 3 over here is based on the fact that phosphate has a -3 charge. But nitrate does not have a -3 charge, so I'm not going to carry this formula with a 3 over here. The other mistake is because there were 2 with the nitrates to carry that parentheses 2 over here. So sodium nitrate is not this crazy formula Na3 NO3 taken twice. That's wrong, okay? Because I have to look at what the charges are. So I'm just going to carry over the symbol for the ion, and this symbol is Na. And this symbol is NO3, and not carry over the additional subscript of 3 or the additional subscript of 2. So I'm going to write a correct formula. Sometimes it's good to cover this side up. You should be able to write this formula without looking at this side. So cover this up so I won't be confused with this subscript 3. And just look up sodium, which has a +1 charge, which you actually shouldn't have to look up, you should know. And nitrate has a -1 charge. So I actually only need 1 sodium and 1 nitrate to make a neutral compound. So there I have my formula, but also after sodium nitrate, I need to put if it's aqueous or solid. And either I remember all sodiums are soluble, or I remember all nitrates are soluble, or if I don't remember either, I look them up in Appendix A2 and find that out, and so this is aqueous. So there's my first step, and I don't need this stuff anymore. There's my first step. I have my products, and I have to have the products written properly. If you get these ionic compounds with incorrect formulas, you will find that it is difficult or impossible to balanced. So these have to be written correctly. So you can check. Barium is +2, phosphate is -3. That's correct. Sodium is +1, nitrate is -1. That is correct. Take a look at your formulas. Are they correct? If the charges do not make a neutral compound, then redo them. All right, these have to be correct. The next thing I want to do is balance this. So the elements on the left have to equal the elements on the right, and the amount of those elements on the left have to equal the elements on the right. And this is where those subscripts like 3 and 2 are going to come into play. So I have 1 barium on this side, and I have 3 bariums on this side. So I need to have 3 on this side. And just as we said before, I can't just make this barium with a subscript 3 because that will not be a neutral ionic compound. But I can put a 3 in front. So there I have it. I now have 3 barium nitrates. So 3 bariums, 3 bariums. That's good. Now, what about the nitrates? And I'm going to think of the nitrate as a unit. NO3 is 1 unit. So how many nitrates do I have? Well, that's a little bit confusing because I have a subscript here too, and also this 3 in front. So how many nitrates do I have? I have 6. 3 times 2, 6 nitrates on this side. So now I go to the other side, and I only have 1 nitrate. Remember, the nitrate group is NO3, so I only have 1 NO3 group. So how do I get 6 NO3 groups? I put a 6 in front. Now let's go to the next. So barium's balanced, nitrate's balanced. Let's go to the next element, sodium. I have 3 sodiums on this side, and I have the 6 in front, which means it goes for everything behind it. I have 6 sodiums on this side. So how do I get 6 when there's a 3 here already? I put a 2 there. So now I have 6 sodiums, and the last thing I have to balance is the phosphates. And if you've done this properly, you might notice that the last ion that you have to balance is probably balanced already. So let's check that out. I have 2 phosphates here and 2 phosphates here. So this is a balanced molecular equation. So 3 barium nitrates, which are aqueous, plus 2 sodium phosphates, which are aqueous, yield 3 barium phosphate and 6 sodium nitrates. So there we have it. And this is aqueous and this is a solid. So this is a molecular equation. But you may be thinking, but we learned in class that things that are aqueous, so these 3 things, if they're ionic and they're soluble in water, they don't stay together. They actually are broken apart. And we wrote dissociation equations. So this is not really together as a barium nitrate unit. This is not really together in water as a sodium phosphate unit. And this is not together in water as a sodium nitrate unit. So now we're going to write a total ionic equation. And hopefully I can write small enough because it's going to be a little bit longer. So let's see what I can do. So barium and nitrate are actually separate in solution. They're surrounded by water, and we looked at some videos that showed that. So now we're going to represent that in symbols and an equation. So barium and nitrate break up. Sodium and phosphate break up. Barium phosphate, because it's a solid, gets to stay together as one thing. Sodium nitrate breaks apart into 2 things. So what does barium nitrate break apart into? It breaks apart into barium and nitrate. When it breaks apart, it's no longer neutral. The reason there are no charges here is because they add up to be 0. But barium by itself has a +2 charge. Nitrate by itself has a -1 charge. And I'm not going to have room, so I'm going to write the aqueuses below. If you have room, you should write them next to it, like up here. But I have barium and nitrate. But I also look at this equation, which I've already balanced. I had 3 bariums and 6 nitrates. So I put 3 bariums and 6 nitrates. All right? So there, I've turned this barium nitrate, which is not together, into 3 barium ions and 6 nitrate ions. Now notice the nitrate is a unit. It stays together. It does not separate into nitrogen and oxygen. Okay? It doesn't separate. It stays together as a unit. So you really need to know your ions. You should recognize that NO3- is an ion. So that is a unit and it will stay together. So there we have that one. Let's do the next one. So sodium phosphate breaks apart into, you guessed it, sodium and phosphate. But once they're broken apart, they have their charges. So sodium has a plus charge, phosphate has a 3- charge. And these are both aqueous. And for space, I'm going to write mine below. You can write them next to it. How many sodiums and how many phosphates do I get when this breaks apart? Well, I actually get 6 sodiums, okay, and 2 phosphates. Remember, this 2 in front goes with everything behind it, just like in a math problem. So this goes with the sodiums and with the phosphate. So I have 6 sodiums and 2 phosphates. Let's do the next one. Barium phosphate is a solid. Yay! I get to save some space here. It does not break apart for the most part. And so we're going to leave it together as barium phosphate solid. Last one, sodium nitrate does break apart into sodium and nitrate. So it breaks apart into sodium and nitrate. And when it's broken apart, this is charged and this is charged. And they're both aqueous. And then how many do I get? I get 6 sodiums and 6 nitrates. And there we have our total ionic equation. Right? Now, for our last step is our net ionic equations. And net problems are easy to do because they're shorter and they follow a simple math concept that if something is exactly the same on the left and the right, we can subtract it off. So this simplifies to 3 equals y, because there was an x on this side and an x on this side. I guess I should have crossed it out like this, because that doesn't work. And then we get the equation to simplify as y equals 3. So let's go here and see what is happen or present on both sides of the equation. So I have 3 bariums on this side, and I have 3 bariums on this side, but they're not the same. Here, they're charged and aqueous. Here, they're combined together with the phosphate, so that's not the same. What about the nitrates? I have 6 nitrates on this side, and I have 6 nitrates on that side. So that is the same on both sides. So for the next one, I can get rid of that. So with a different pencil, I'm going to circle that, okay? And we're going to eliminate those, the ones with the circles. What about the next one? Sodiums. This has 6 sodium ions aqueous and 6 sodium ions aqueous. So we're going to get rid of these. All right? So what is not circled? What is left over? We have 3 bariums. Oh, let's check the phosphates. Are they the same on this side? I've got 2 of them, but here they're combined as a solid, so they're not the same as this. So what do I have left over that's not circled? I have 3 barium ions, which are aqueous, reacting with 2 phosphate ions, which are aqueous, to form barium phosphate, which is a solid. So what does this all mean? It means that the sodium and the nitrates didn't do anything. They were floating around in solution before, they're floating around in solution after. Sometimes it's called a spectator ions. They're just watching, they're not doing anything. The only part of this equation that's actually undergoing a chemical reaction is barium ions are finding phosphate ions and precipitating out. You may notice that this precipitation equation is the opposite of a dissociation equation. For a precipitation equation, ions come together to form a solid. For a dissociation equation, a solid breaks apart into ions. So when do you have which? When you precipitate out, that's usually when something is insoluble in water. When something is soluble in water, it breaks apart and separates. So barium phosphate's insoluble, and it produces this precipitation reaction. So if I had to go directly to this equation first, I could find out the solid that I have and then figure out what ions would go together to make this solid. So I could almost go from here to here without doing total ionic. So why do we do total ionic in the first place? One, because it's a good representation of what's really going on. At the beginning, at the instant right before they're mixed, we have all of these ions that are separate, surrounded by water, floating around in solution. After the mixture happens, they're still floating around. The bariums run into the phosphate and stay together as this solid because that strength of attraction is so strong. It stays together and eventually probably ends up at the bottom of the beaker, and the sodium and the nitrates are soluble. They're still floating around. So there we have our three types of equations. And if you notice, if I followed the numbers all the way through, I didn't have to rebalance them. So I have 3 bariums, 2 phosphates, 2 phosphates. So if you follow the initial numbers, you will end up with a balanced net equation, and you will also end up with a balanced total equation. So hope that helps you to write your own molecular equations, total ionic equations, and net ionic equations. Thanks for listening.